Welcome to session number 6 about functions. And we have already began to understand quite a lot about C# programming. And today as well, we'll talk about stuff which is very important for all programming languages. Of course, I will show it in C#, but of course, the knowledge you will learn today, you are able to use afterwards in all programming languages, which can be sometimes look a bit different, but as we know in C++, in C, in Java, in C#, it will look kind of the same. In Python can look differently. But today what we learn with functions, part 1, will be useful for all programming languages. So I started with, as usual, I will start with my Microsoft Visual Studio project. And sometimes we need some component which makes our life easier, which does some work for us. And that's why functions were invented. And maybe if you remember from mathematics in school or high school or university, you remember a function is you put an x value into the function and you get a y value out of it. So in other words, it's like a black box. You can throw some stuff into it and you can get some stuff out of it. The cool thing in programming is if you create functions, you will always be able to throw a lot of stuff into it and you get some stuff out of it. So if you want to do some operations which you have to do all the time again and again and again, and you want to have like a slave, or you want to have like a machine which does stuff for you, for instance, like a washing machine or like a kitchen or like a robot, or like you have a computer game and you have a function called shoot, or you have a function called jump, or you have a function called run, or you have a function called drive, whatsoever. You want to create boxes, you want to create components in your application which make your life easier, which do some stuff for you. And that's why we have to use functions. And actually, we're already using functions all the time. We are using the main function, and the main function is called main. That's why it's a function. And we will learn about how we create functions and how we use them. And we will learn how to create different versions of functions. So the first function we already used was the main function, which is this function. And to show you the whole process, how to create a function, I will stick to a very easy example. I will just add 2 numbers. I will show the whole process by adding 2 numbers and computing the sum. And in the future, we will use functions all the time, because we have to create boxes which do some work for us. So the first thing is, I just would like that you guys just look what I'm doing, not programming with me, because I will delete all this stuff afterwards. And in just the first 10 minutes or like the first 5 minutes. But in the very beginning is to understand why we have to use functions, or why functions are very useful. So the first, I would like just to create an application which adds 2 numbers. And as I said, you just have the possibility just to watch and just look what I'm doing. Give me a number. I just want to show why functions are important. Give me a number, or give me a first number, maybe. I just do a very easy example of adding 2 numbers, which is not very difficult, but which will show the overall process. Int number 1. As we know, this is a declaration in the memory, and this is like a command. And we know, for instance, to get the number from our keyboard, we will write number 1. convert to int 32, console.read line, probably like this, and I will copy the second number again and create the second one, copy this stuff, and again give me a second number. As I said, probably not programming with me right now, just show what I'm doing, because this application makes no sense right now. Just show the overall process. And then I could create or declare a variable int. Maybe I just call it not, I don't call it sum, I call it result, which can be used in different ways. I call it result, and I can type number1 plus number2 semicolon, and I can write right line, the result is blah, 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 result, here you go, which should output the overall result. As we have followed the first sessions, this would be just a piece of cake, what we are programming here, which is very easy to understand. And just what we're doing, we are just declaring some variables, getting some values inside, and then printing out the result. But what if we could create something? We could create something which does the overall work for us, which adds two numbers, which is a function, maybe called adding function, or just add whatsoever. We can call it quite a lot. And this function has just the purpose to add two numbers, nothing more, nothing less. Of course, we can create functions to do whatever we want, but we could begin with a function adding two numbers. How can we create this? Okay, so we just derive from this version and want to create another function. We want to create our functions. How can we create functions? The first thing is, our goal is to create a function which adds two numbers. Okay, that's our goal. We never have to forget what's the goal of our function. Okay, what's here? Hast du den Bildschirm geteilt? Kann ich sehen? Yeah, I am showing. Okay, that's strange. I just share it again. That's our main goal. The main goal is how to create. So the main goal, do you see the screen now? Hopefully, okay. Okay, strange. Okay, our main goal is now we wanna, if you see at this example is we wanna create a function which adds two numbers, and adding these two numbers and then printing the result. If we create functions, we can always begin in C# before the main. So I will make some space before my main function, but please be advised to use it inside the main class. Okay, but just always to write functions before the main. It's always advised in any programming language to write it before the main function. Okay, if we create a function, we can call it whatever we want. I want to create a function which adds two numbers. That's why I call it add. The main structure of a function is add, parentheses, and curly brackets. And now I would advise that you guys are programming with me, not just watching, just also programming with me. The name of a function is always like the name of the function, parentheses, and curly brackets. And inside the curly brackets, you write what the function has to do. Inside the function, you write what the function has to do. What the function has to do inside. That's very important. And that's the function name. And inside the parentheses, there you can write the ingredients of the functions, which we will deal afterwards. So what's inside the function is called the function body. It's called the function body. And the function body is a very important part because it tells us what we want to do. Okay, the first version, and now we'll begin with the first version of functions. The first version of functions, first version of functions, which is sometimes in the beginning the most difficult to understand, but afterwards it's the easiest to understand. But in the beginning can be the hardest one to understand. Okay, listen carefully. If we want to create something which does something for us, but when this stuff is over, I don't care about the result. I just want that this stuff is over. Then I call it void. It's a void function. In other words, if I create something where I don't process the result of the function further on, where I don't use the result for further computations, I call it void function. It's called a void function. Void is a very important word in programming. Void means nothing. And nothing means in this context, it's not returning anything. It's not returning, or it's not given a return value, which sounds very cryptic at this point, which only means it does all the stuff which is in the function, and then it's over. Okay, I will show you different versions, and then you will realize it. In the very, very beginning, when you hear the word void, it doesn't make any sense. If we create different versions of functions, you will understand the word void after a certain while. If we want to create something which does something, but afterwards it's just finished, it's not delivering or transferring the results to anything else or anywhere else, it's called a void. And that's why we write in the first version, we write void. Void means in this context, I just want to have a function which has the name add, which does stuff for me. But when this function is over, it's over. Okay, no computation, no further computation of my results. Okay, my function void can do whatever I want. So I can copy or just cut all my stuff from my main. I can copy it inside, or I cannot copy, I just extract it and cut it into my function add. First version. I just cut it into my function add. So I have a function which does something for me, and every time I use this function, the code inside of this function will be computed. Every time inside the function, the code will be computed. Every time. So this is the function add, which does, when I use this function, which does the following: creating two numbers, creating a result number, which is an integer, reading and writing and reading, writing and reading, computation of the result, and printing the result. But think about it. A function is like a very fancy car. you buy a very fancy car, but if you don't use the car, it's just useless, because this code is not delivering any error. This code has no errors, but if I compute it, I don't get anything. I don't get any result. Why? Why is this the case? This is like the very fancy car problem. If I have a nice function which does nice fancy stuff, but I never use the function, then it's just useless. That's why I have to call the function. And that's why it's a very important word, how to call a function. So I want to use this fancy function. How to use a function? The function is used by typing the name of the function, following parentheses. That's the first version of typing function. And that's the stuff here is typical in all programming languages. In C#, in order that we can use it, we write static. But don't try to understand static right now. Just type static, which doesn't make any sense in most programming languages right now. But just for all programming languages, it's important that you follow this structure. But in C#, just type static in order to make it work. We will talk about static in some near future, in some weeks, but not now. Static is just use static in the beginning. So this is like we drive with our fancy car. We use our fancy car. And here is the car. The function add is our car. This is our car. But if we don't use it, it's useless. And here we use it. So what happens now is we know as a starting point of our application, the main starting point of our application is the main function. So in other words, the project begins to work at line 31, or actually at line 28. So it jumps into the function main, and nothing before from line 9 to line 26 is computed before, because the program jumps in the very beginning to line 28, where the main is, which is marking our starting point. So that's where it jumps to add, and then it tells us, our computer, and says, oh, Jesus Christ, do we have a function with the name add? And the computer says, yes, I have a function called add. And this function called add is here. So please do all the stuff which is in the function. And it does this stuff, this stuff, this stuff, this stuff, this stuff. And when it's finished here, 25, because it is void, it says, okay, just exit this stupid function and jump out again. So it jumps out at 25, jumps out here, and it goes back to 32. So the whole pipeline is jumping 28, add, computing everything which is in the add function, everything in here, and then jumping out of the function again by processing line 32, and then it's finished. So if we compute this stuff, if we compute it, we see first number is 4, second number is 5, the result is 9. What's up? That's the first version of a function. And of course, I can, just to show it again, I can copy functions. I just copy this function, I copy it, I paste it before the main, I call it differently. Maybe I call it subtract or multiply, whatever, multiply multiply, whatever. And I use the same code. And instead of writing number 1 plus number 2, I do like number 1 times number 2. And if I want to compute my function, I copy the name of the function, go to the space or to the position where I want to call my function, write parentheses and semicolon. So after my add function is called, the multiply function is called, which just does the same as the add function, but gives us the result of a product of multiplying two numbers. So that's the first version of a function, which is very often used, for instance, very easy and plain text messages or long stuff, which is, for instance, like a menu, and then you call a function which is called menu, and all the stuff which is inside the menu is called, or everything which is just not having any ingredients and not returning any results. That's why the first version we learn today is void functions, and void functions without parameters, it's called. That's the first version we learn today. First function, void function, not returning any value. I know this sounds still cryptic, but will be better. And without parameters. Parameters means ingredients inside of the function. What parameters mean, that's something which I will tell you now. That's the next version of a function, the next step. Okay, first version of a function, and you can call function whatsoever. I wouldn't just begin with numbers. I think numbers are not allowed in C#. In most programming languages, they are not allowed to start with numbers, but otherwise it's kind of okay. And I would always suggest writing functions with small letters, not with capital letters, okay? Classes should be huge capital letters and functions should be small capital letters. I know in C# it's a bit strange because the main function is also with a capital letter, but C# is the only programming language which uses functions with capital letters. Even though if you think, okay, why does this matter? This matters to us because we have to find a language which is usable for every programmer. And if even though a Python programmer sees this code, he has to understand what's going on. That's very important. So the next version of a function is a function with no return value, which is like a void again, but with ingredients. That's the next version of functions. And I will use the same example. I will use the same example to show what's going on. And I will call it void add 2. I will call it void add 2. And I will create it also before the main, always before main. Never use function names again, just always use functions in a different way and names in a different way. This function, when it's finished, it's finished. It's not computing and it's not transferring the results to any further position, nowhere. But this function will have some ingredients, and the ingredients are inside of the parentheses. They're inside here. And which kind of ingredients do we have? We have 2 ingredients. Why? We have 2 numbers which we wanna add up. That's our goal. we wanna add two numbers. So we take two numbers as ingredients. In the very beginning, it's always very tricky to understand what's an ingredient. But ingredients are all the stuff we have to use to compute our results. So not the result is an ingredient because we create the result out of our ingredients. So we wanna create a result depending on two numbers. So those two numbers are our ingredients. So we create a function, and in order to use a function with ingredients, we write the ingredients. Int number 1, comma, int number 2. Here's the main structure of the ingredients. If we want to use two numbers, two integers, then we write int number 1, int number 2, or int x1, int x2, or int blah 1, int blah 2. It doesn't matter what's the name of this stuff so much. It's just important that the data type, integer, is correct and the amount of ingredients is correct. I will not use the word ingredients anymore because in the parentheses, those two ingredients are called parameters. So I will call this stuff in the future parameters because they are parameters. And in this example, we have two parameters, an integer number and another integer number. And we want, every time we call this function, we want to create the sum of two functions. And we get number 1 as a parameter, and we get number 2 as a parameter already. So we know the values from number 1 and we know the value from number 2. We know it already. We know that this will be 3 and this will be 5, or this will be 10 and this will be 20. We know it already. And that's why this version is very, very popular, because we know already, we get it from somewhere else. We get this information from somewhere else. So we can use those variables now. We can use them to create a result, like result equals number 1 plus number 2. As you can see, we get those two parameters from somewhere else. We get those two parameters from somewhere else, but then we can use those parameters. The only thing we have to create is a result. We have to create a result variable, but number 1 and number 2 we get from somewhere else. So, and then like before, we wanna create an output like here, and we type console write line, the result is result. That's the main structure of a function with void, second version, with function with void and with parameter. And with void means without return value, which is sometimes in the beginning a bit hard to understand, but which means when this stuff is over, it's over. It's not sending the result somewhere else. It's just printing the result, and that's it. It's nothing more than printing the result. So, but how do we call this function? How do we call it? For instance, we can call the function again by typing the name of the function. The name of the function is the name of the function. And in order to make it work in C#, we type static. We type static, and we know the basic structure of the function is the name of the function and the parentheses. But this function expects two parameters. This function expects two values from my input. So I can, for instance, type in 2, comma, here we are, 2, 10, for instance. So what's happening now is the 2 will be copied to number 1, and the 10 will be copied to number 2. 2 will be copied to number 1, 10 will be copied to number 2. Or of course, I can make console write line here, console write line, console read line, and use, of course, variables. I can use variables here. I can use variables here, of course. I can do that. I can write like stuff here, just to show what happens. I can, of course, I can do like stuff. Just give me a second. So I will delete it afterwards, so no worries. I just want to show you some stuff. Of course, I can create two numbers here, two numbers here, and instead of feeding my function with 2 and 10, I can feed my function, of course, with number 1 and number 2, of course, which is, of course, much more interactive than feeding my function with 2 and 10, which is just useless, because I want to have an interaction. I want to have an interaction. So this is the second variant of creating a function where we have no return value with parameters is here, and a function without return value and without parameters is here. That's the first step. So in my opinion, which should be very wise to do here, is to create, I don't know, and some people like to create a calculator with a switch, and instead of typing the values, they use the calculation, or they use everything they want to do, solve quadratic formulas, solve whatever they want to do, mathematical equations, by using functions. And I just can advise you guys that you just write an application. You can begin with a calculator, with fancy stuff, quadratic formulas, whatsoever, physical stuff. So which you jump in, or which you paste in all the different parameters. Of course, you can do like 3, 4, 5 parameters, not just 2, 10, 20, and then calculate a result, and that's it. You can always do that. But of course, we are course today, and of course, there's already a lot to do for you guys to program, but I want to show you a third version, and we will use functions all the time now. All the knowledge we have learned so far, we will use now in the future more and more together. So we will use array lists, we will use arrays, we will use for loops, we will do whiles, and so on. So we are kind of finished with the basic knowledge, and we will use this basic knowledge now all the time to get more advanced knowledge than in the future. But to understand functions completely, first of all, you have to write your own functions, of course. But the third version of a function is very important now. And this is not a void function. So I will show you the third version of a function. The third version of a function has the same purpose. It should add two numbers. And I know I chose a very simple goal, but it's very important to choose something simple to understand the overall process. The third version of the function, I call it third version of the function, third version of the function, which has parameters and has a return value, which means no void. The basic structure, as usual, is the name of the function. I call it add3, and I create the basic structure of my function. I create the basic structure of my function. And as before, I wanna create a function which adds the sum of, which adds the two numbers and calculates the sum. So I just copy the same stuff from before. And I copy the line 51 and I copy line 53. I copy this stuff inside here because the calculation of my function is kind of the same all the time. Very easy. But now, maybe I want to use the result afterwards. Maybe I want to calculate something in addition afterwards. So maybe I don't want to, that at this point the function is over. Maybe I want to use this variable afterwards, or maybe I want to use the value of the variable afterwards. So I want to send it further. I want to send it, I want to transfer it back to where it started, back where it came from. So that's why we don't use void here. We tell the computer to return the result. We want to return the result. So that's why we use a very important word which has the name return. Return is very important for all programming languages. But how do we tell the computer that this function returns the result? The only thing the computer wants to know is which data type is result. Result has the data type integer. So I have to tell my computer and I have to tell my function which data type am I returning. So that's why I type, because I am returning an integer, I type in integer. That's the only thing I have to do, which means I have to check which data type I'm returning, and I'm returning a data type as a int. I'm returning an integer, so that's why I have to type in int. As you can see, the difference, and now we make it in C# again, which is just C# stuff to type in static. But as you can see, the difference now is we have the same amount of parameters, but when this function is over, it's over. But this function returns a value and sends this value further on and sends it somewhere. But if it sends it somewhere, I have also to catch it. I have to catch it somewhere. And if I don't catch it, the sending process is useless. So that's why we have to catch the result somewhere. How do we catch it? How do we catch the result? in order to catch the result, we call the function. We call the function, for instance, we call it here. We know by typing the name of the function and by typing the variables, number 1, comma, number 2, semicolon. And I know this function returns a value. This function returns a value. So that's why I have to save the result of this function. So in order to create a result, I can, of course, create the variable. I call it x this time, that we can see that it's different. I call it x. Here we go. And to get the value, we know add 3. If I check add 3 is returning a value. It's returning result. So I have to catch this value from add 3. And how to catch the value from add 3 is by typing, for instance, x equals add 3. And of course, I can call it not x, I can call it result as well. Of course, I can call it r. I can call it whatever I want. But I have to understand, if we compare add 2 or add 3, add 2 does stuff. And when add 2 is finished, it's finished. But add 3, on the other hand, it computes a result and then transfers the result back to the main function. And what means that I can, of course, print the result. I can, of course, print the result. Maybe I type blah, 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 result and plus result whatsoever. And finished. So I can do that. So as we can see, now we have 3 different versions of functions. We have 3 different versions of functions. The first version, has no parameters, has no return value. That's the function code. Function code. The second function, the second version of a function, has no return value, but has parameters. So it's a void function with parameters. The first one is a void function without parameters. And the third version of a function is a function with a return value and parameters. So those 3 versions are very important and essential for all further computations. And the one thing which happens here all the time is people get used to some version of functions very much, and they begin liking some versions of functions. They say, and they try to solve all the problems they have with always the same version of a function, which is stupid. You have to have all different versions in your petto. You have to be able to implement all different versions of a functions, because sometimes you need a function with a void, sometimes you need a function with a return, sometimes you need a function without parameters, sometimes you need a function with parameters. So that's why don't get used to your function or to one version of a function. You have to be able to implement all those 3 versions all the time. And it's in every different scenario, you find different, you have to be able to use it in a different way. And that's what you have to understand. Sometimes it's this version is better. Sometimes this version is better. Sometimes this version is better. So you have to be prepared that each of those versions are very important for all the further computations, because we will create functions all the time. Okay, so this is one of the most important knowledge we have learned so far, and we will of course combine it now in the future with array lists, with arrays, with for loops, with do whiles, and so whatsoever. So the next sessions we will have will be just applications. We will try to write some programs with the different stuff which we have, to show how we can use functions, how we can do stuff. So I'm finished now with my input, and I will stay here as long as you need. But very important now, I would just suggest, if you're having difficulties, I would just begin making a calculator with 3 different stuff, or 5, 6, 7 different calculations, or writing currency exchanger or currency changer, or write your own functions with parameters, without parameters, with return value, without return value, whatsoever. But write different versions and call different versions and get used to functions. Even in Python, functions look kind of the same. So functions are the only thing which are kind of the same in all programming languages. Okay, so I will stop my recording now, and I will be, of course, I will be available now for all your questions. And please begin thinking, why is it important? And try to make your own stuff now. Very important.